All right, here we go. Lesson 13, practice problems. Find the volume of a pyramid whose base is a square and side length 6 units, height of 8. Okay. So first thing I would do is draw. So just draw the square base. Does it have to be perfect? No. Pyramid has an apex. There's the apex. Square 6 by 6 because the side lengths are 6 and it's a square. And the height is 8. So h equals 8. Okay, so for these, because it has an apex, any of the solids we deal with that have like a point where all the vertices go to, there's a vertex, 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 vertex. So from the base, each vertex goes up to the same point. That's called an apex, the top. Any of those, volume's going to be base height over 3. So the base is the area of the base, and that's 6 by 6, which is 36. So you just say B equals 36, and then height we were given, that equals 8. So you just got to plug these in now. So the volume is 36 times 8 divided by 3. 36 times 8 divided by 3. So 96. And then you don't just say 96. You look for the measurement. So they're in units. So that one you say cubic units. Volume's got to be in the third degree. Okay, a cylinder has radius 9, height 15. Cone has the same radius and height. Find the volume of the cylinder. Okay, so let's draw it. Cylinder, radius 9, height 15. I'm just going to draw like a random cylinder. This is not like a perfectly to scale. This is not like a radius of 9 and height of 15, but we're just going to label it that way. Okay, so radius is 9, height is 15. Now the cylinder is just simply base times height. Now the base right here, big B, is the area of this circle. A circle has area pi r squared. So big B is the area of the circle. So pi times 9 squared. So the base will equal 81 pi. All right. Height, we already know, is 15 because it was given. So you're just plugging things in now. So it's 81 pi times 15. Easy peasy. Just do 81 times 15 on a calculator. 1215 pi. And then you got to make sure you get the right label. So I always look for it. It's inches. And then just put IN and then to the third power. So there's the volume of the cylinder. Okay, now the cone, same radius and height. Now cones have an apex. So this cone has an apex right here. Meaning the volume is base height divided by 3. Now they said it was same radius, same height. So 9 and 15. We already figured out the base, which was 81 pi. The height's 15. So for this one, you just say volume equals 81 pi times 15 divided by 3. And we already know 81 pi times 15 is 1215 pi divided by 3. So 405 pi inches cubed. All right, what fraction of the cylinder's volume is the cone's volume? What fraction of the cylinder's volume is the cone's volume? 1/3. And if you wanted to run it, you could just do 405 pi divided by 1215 pi. Okay, each solid in the image has height of 4, okay? So we know that the height of both of these is 4. The area of each solid's base is 8. So we're just going to say B equals 8 on both of these. B equals 8. Okay, a cross section has been created. They're talking about this one. In each, by dilating the base using the apex as the center and a scale factor of 0.25. Calculate the area of each of the two cross sections. Well, I know the area of each of the cross sections is going to be the same because we started with the same base and we used the same scale factor. So this one's pretty easy. B equals area, right? So the base represents the area. So you just got to set up that old equation that you know, which is A times K squared equals A prime. Now, A is 8, K is 0.25. These are given to us because the base is 8. That means the area, this A is 8. So you say 8 times 0.25 squared equals the area of these cross sections. And remember, this formula was in the past, so you already know this. Now, personally, I do this first. So I go 0.25 x squared equals. It's 0.0625. And then I multiply that times 8. So you're going to get 0.5 equals area prime. So you want to write it in a sentence. The area of each of the two cross sections is 0.5 square units. Area is always in the second power. And that's your answer. Okay, suppose a new cross-section was created in each solid, both at the same height, using some scale factor K. How would the areas of these two cross-sections compare? Explain your reasoning. The areas would be the same. And can be represented by A times K squared, or 8K squared. K is the scale factor. Because we have a starting area times the scale factor squared equals the new area. And they're saying any scale factor K, so you just leave it as K. So this is the representation of the new area of any cross-section, of the cross-sections at any scale factor. All right, cool. 4. Select the most specific and accurate name for this solid in the image. Now, there's no apex. There's two triangles that are looking like they're the same. And then we got upright. And we got right triangles also. So my initial thought is, all right, this is a triangular, because the bases are triangles, prism. So just look for the triangular prism. Yep, right here. That's the only one. And right just means it's upright. So and these right angles give that away. Okay, a solid can be constructed with 4 triangles and 1 rectangle. What's the name for this solid? So you know if there's only 1 rectangle, it's probably got an apex. If it had 2 rectangles, it'd probably be a prism. But anyway, here's your rectangle length times width, right? This is gonna be the base. And then watch this. Here's your apex. So draw this. And then look for the triangles. So 1 in the back, 1 in the front, and then 2 on the sides. So 4 triangles, 1 rectangle. Check that. That's a pyramid. And the base is a rectangle, so you're going to call it a rectangular pyramid. Let's see if that's the answer. Rectangular pyramid. There it is. A. All right, 6. Find the volume of the solid produced by rotating this 2-dimensional shape. This is the 2D shape. Using this axis shown. So this is like a rotisserie grill or something, but basically you're going to have a cylinder with a hollow portion. The hollow portion is going to be the white space. So this thing goes 2 over here. And we got another. So we got a cylinder here. And if you want to draw it like this, you can. But anyway, this section right here in the middle is hollow. Now, if you look at it this direction, it starts to look a little clearer, but this is actually going to be the height right here. So the radius from here to here, the whole thing, radius is 3. And then this radius is 1, the little guy. Radius is 1. The whole thing is 3. The small hollow portion is 1. And then the height is 1, 2, 3, 4, 5, 6. Okay, so kind of rotating it on you, but anyway, height is 6. We're going to start with find the volume of this cylinder with the hollow portion in the middle. This is the hollow portion. We go volume of the whole thing minus volume of the hollow portion. And that'll give you the volume that we need. So the whole, the radius is 3. So you could even say a radius is 3, height equals 6. For the hollow portion, the radius is 1, and the height still will be 6. And then you need to use pi r squared times height, because that's the formula for volumes of cylinders. So we're just going to plug things in. If you want to write pi r squared times height minus pi r squared times height, that's a good idea. Just rewrite the formula and then just plug things in. You already noted that the radius was 3. We counted them. So pi 3 squared times 6 minus pi 1 squared times 6 will equal the volume we need. 3 squared is 9 times 6 is 54. So the whole thing's going to be 54 pi. And then 1 squared is 1 times 6. So 6 pi. Keep the pi's there. 54 minus 6 is 48. Don't forget the pi. And then, let's see, you're going to say cubic units because we're talking volume. And they didn't say it was inches or anything. All right, so that was 6. Cool. 48 pi cubic units. Number 7, this is a tough one. This zigzag crystal vase has a height of 20. Okay. So what I always like to do is just label the figure. So height is 20. The cross sections are parallel to the base are always rectangles that are 12 by 6. So check it out. We got like a base, which is a rectangle. And the base is always, I'll draw the base down here. 12 by 6. So the base will always equal 12 times 6, because it's a rectangle, which is 72. 6 times 10 is 60, 6 times 2 is 12, 60 plus 12 is 72. Okay, so the base is always 72. And even though it zigzags, what you're going to notice is this area is the same as this. So it's basically like a cylinder. So, or I should say a prism, sorry. So this one's just going to be volume equals base height, because there's no apex. You said the base was a 72, the height is 20. Easy peasy, so you just say volume equals 72 times 20. 72 times 2 is 144. Add the 0, and then we got centimeters to the third power. If we assume the crystal has no thickness, what would be the volume of the base right here? Volume equals 1,440 cubic centimeters. The crystal is actually 1 centimeter thick on each of the sides and on the bottom. Okay, so there's like a glass thickness, each of the sides and the bottom. So I'll show you what the original was. The original was like a rectangular prism, right? Okay, so we originally had these dimensions. 12 by 6, and then height of 20. Okay, now they're saying the crystal is actually 1 centimeter thick on each of the sides and on the bottom. They didn't say the top. They're just saying the bottom and each of the sides. Okay, so that would mean 12 minus 2, right? And then on the bottom, so instead of 20, it'll just be minus 1. Approximately how much space is contained within the vase? That's the part that's doesn't have the thickness. Like, how much could we fill it up with, basically? So you're going to just essentially change this zigzag base or zigzag crystal to these dimensions. And because of Cavaliere's principle, you know that this can just be written 10, 6, 19. Even though it zigzags, because the cross sections all have the same area, you're golden. So, all right, so volume equals 10 times 6 times 19, which equals 60 times 19. 60 times 20 is 1,200. And since we're down 160, so that should be 1,140. So volume is 1,140 centimeters cubed. Let me just triple check that I didn't mess that up. 60 times 19, yeah, 1,140 cubic centimeters. All right, number 8. Trapezoid has an area of 10 square units. So A equals 10. What scale factor would be required to dilate the trapezoid to have an A prime of 90? Well, that's easy. You just go A k squared equals A prime. So 10 times k squared equals 90. Divide by 10 because we're trying to isolate k. K squared equals 90 divided by 10, which is 9. Take the square root of both sides. K equals 3. Done and done. All right, 19 minutes, no big deal. The key, though, is to understand these. So even though it's 19 minutes on my end, you might have to like pause and rewind and don't stop until you like really get it. I think that's even a song lyric. So just copying the problems is one way, but you need to understand the big principles. All right. Anyway, good job. Keep going. We're almost done. All right.